This is a GCSE physics lesson all about distance time graphs. So, what I want you to be able to do at the end of this lesson is be able to plot a distance time graph and describe the motion from your distance time graph, then draw tangents onto the graph to calculate the speed. So, these are the four types of distance time graphs you should be familiar with from good old GCSE, Key Stage 3. So, what I'm going to do here is, first of all, a stationary object is simply going to look like this, where you've got a horizontal line. Trying to get it horizontal the best I can. There you go, and then horizontal. Now, the reason why it's going to be horizontal here is because with time isn't the distance going to stay the same. And it can be horizontal at any point here, depending how far it's traveled at a certain time. If you then got a constant speed, you should know it will form a straight line like this. It must form a straight line because it's going to go equal distance and equal time. Now, if you've got two lines and one going here, and I'm going to now draw a second line going up here like this, the steepness or the gradient, and it's the posh word they use, is gradient basically means the steepness represents how fast it's traveling. For example, this is going to be a slow moving object and this is going to be fast. The reason why that happens here is because if I do a line going across like that, this can say be example 10 seconds, which means that one it's traveled 20, and this one I can say dotting across is traveled at 40 meters. Doesn't it make sense? At 10 seconds, if this one's only gone 20 meters, that one's gone 40 meters, this person must be moving faster. So if you've got an object, the steeper or the bigger the gradient, the faster it is traveling. Now the tricky ones come down here into acceleration and deacceleration. To show acceleration, the graph looks like this. And the reason why it looks like that is because the line gets steeper and steeper and steeper and steeper. Because again, if the gradient increases, the speed increases. If you're showing deacceleration, the object is slowing down. Therefore, doesn't it make sense? The graph looks like that. Because now the line gets less steep, less steep, less steep, less steep. Therefore, as the gradient starts decreasing, the speed is going to decrease as well. Those are the four graphs you're familiar with. Now, to plot distance time graphs is I'm going to take you to this. Now, this is a very nice little simulation. What you've got here is a lovely yellow car. Now, this lovely little yellow car is going to travel along the road, and we're going to record the distance it travels with time. Now, it's going to do this every 5 seconds. If you want to, you can plot this time graph yourself, where you've got 0 seconds going right to 55, and you record the distance every 5 seconds. Now, keep an eye here of the speedo. The speedometer is going to show the speed in kilometers per hour and also in meters per second. So at 0 time, it's gone 0 distance. Now, as it goes along, every 5 seconds, what it does then, you can record the distance. That was 16 meters. At 10 seconds here is going to be 76 meters. Then at 15 seconds is going to be 186. At 20 seconds, I can see recording here is going to be 334. So the speed is going up. Now it's a constant speed. 25 is 484. And at 30, it's going to be 634. Going down then to 5, it's going to be 784. You see it's slowing down now. At 40 seconds, it's going to be about 904. 45 seconds, it's going to be 974. 50 seconds, it's going to be 994. And 55, now it's stopped. It's going to be 994 as well. Now, what you can do now is you can see these are all the values they reckon it's going to be. Now, looking at that, it's quite really hard to work out the full motion of the vehicle. But as soon as you plot a distance time graph, it comes very, very clear. Now, what I showed you on the previous slides, can you see here, the steepness increases, therefore you've got acceleration. Here, can you see you've got constant speed. Here, can you see the gradient decreases, therefore you have deacceleration. To the point there, the last 5 seconds, it stops. So when you see a distance time graph shown like this, you can see the motion of the vehicle very, very easily. That's why we do distance time graphs. So To go with that then, what you can do is you can work out the speed by drawing a tangent. Now, what I mean by a tangent, you draw a line along here where it was going at constant speed. And you see a line going perfectly straight along here. Now, I can work out this constant speed at this point. And what I need to do is work out the change in distance over the change in time. So what you do then is you simply in here is you can see the car has traveled from 200 meters up to 800 meters. Therefore, the change in distance is going to be 600 meters. Then what you can see is the change in time, or what it's going from 36 seconds to 16 seconds. And the difference in time is going to be 20 seconds. Hence, what you can do then is you work out the speed by doing distance divided by time. 600 divided by 20 equals 30 meters per second. So now I've gone through how you plot a distance time graph. Sometimes you can get a graph like this. Now here, again, what you can see the steepness increases. And what they can do now is they can ask you to work out the speed at this point here. So if you've got the speed at that point there, what you do is you then see the steepness is increasing. Now what you do now is you draw a tangent to a line. So what you do is take that point there, you draw a line showing the steepness at that point, and therefore the line is going to be in green. Then you draw your triangle. Now from this point here and that point there, what we do in maths is you write down a delta S, and that delta S represents a change in distance. Then the time goes from 9 to here, and we call that a delta T. And another equation you may see written down where basically, I'm going to correct that now, is your distance, try again, is going to be, your speed is going to be, get the right symbol in a minute, is going to be V, which is going to be delta S over delta T. And that's going to show your distance with time. Therefore, your delta S is going to be 140 minus the other one here, which I'm going to say is 120. Therefore, then you work at your change in time is going to be 9 minus 4. You then put that into your calculator, you get 120 divided by 5. Now, when you put that into your calculator, you then get 24 meters per second. And it's very important in an examination question to show your two values you're taking from here to there, 140 minus 20 and your 9 minus 4, and show all the working so you can gain out the answer. Now, I'd encourage you to do this. You can do stuff on here, but you can, on this one here, you can see again the speed is going to increase. And what you can do is you can find out the speed at any time. You can take it here, you can take it there. What you got to do each time, you've got to draw a gradient, and drawing the gradient is hard. Therefore, if I was here, I'd roughly draw my triangle a bit like that. And then what I'd do now is I basically would take my triangle to be dotting the lines down here and that steepness. And then you can take your values from the graph. When you're going here, then now what you're doing is you're drawing a line, and I'm going to try and draw you and show you the gradient here, which pops out. If I get this hold of this one, it's going to change. And now you can see the line, going to that point there is you've got to draw a gradient, and I got the gradient slightly out, it's much harder to draw, and it's probably about there. That's a very better gradient. We can see in the yellow. But you can see here the steepness changes, and you actually have to go working out the speed at these different times. Okay, so to summarize, I've now shown you how to plot a distance time graph. I've described the motion from a distance time graph and showed you how to tangents to calculate speeds.